Hi everyone, we are on page 6 in our note packet, so we're looking at 2.3.1. I can interpret rates of change given linear functions in different representations. If you have not done the lesson for 2.2.1, you need to make sure that you go back and do that first before doing this lesson. So we're going to get started. And we're going to go through 4 examples of 4 different representations of how we could find slope. You might remember some of it from middle school, or you might not. So you could be given any of these, and so we need to figure out and know how to find slope from all of them so that we can answer all the questions. So whenever we're given a graph, what we need to do is we need to find 2 points that are on the line, and we want to count rise over run. So we're going to count our rise, which is our vertical movement, and then our run, which is our horizontal movement. Rise is always on top, run's on the bottom. And so if we look at our line, we do have 2 points given to us. If we don't see actual dots, we just want to make sure that it crosses at a nice corner on the grid. And so what I want to do is I want to count my rise and my run. So I'm going to start at this point here. And if I'm going up and down, I actually need to go down to get to this point. So I'm going to go down 1, 2, 3, 4. And because I went down, that is going to be negative. So my rise is -4. So over here I have -4 as my rise. And then I don't think you guys will see yellow, so I'll use purple. Wherever I left off, I need to do my run. So I need to go 1, 2, 3, 4, 5. And I went to the right. So that's going to be a +5. So my run is a +5. When I look at this fraction, I cannot simplify it. So I have 1 negative on top. 4 and 5 don't have anything in common except for 1. So my slope, I'm just going to rewrite it so it's the same color, is -4 over 5. So that is my slope, and that's how I find it when I'm given a line, when I'm given a graph. We're going to go to the right. If we have a table of values, all that is a bunch of coordinate points just written differently. So we learned how to do slope from a pair of points. Same thing here. So this first one is technically x comma y. Those can be written in points inside parentheses. We just have a ton to choose from. I have to choose 2 points. It doesn't matter which 2 points I choose. I tend to choose the smallest positive numbers, so it's less work for me. Because if I can choose 1 and 4 instead of 5 and 16, I'm going to do that. So I'm going to label this. This is x1, and this is y1, and this is x2, and this is y2. So I am going to use my slope formula, and if we remember from 2.2.1, my slope formula is y2 minus y1 over x2 minus x1. So I'm just going to write that, y2 minus y1 over x2 minus x1. So this is my slope formula. So I want to go ahead and plug in my values. So y2 is 4 minus y1 over x2 minus x1. When I simplify that, I get 3 over 1. 3 over 1 is just going to be 3. So my slope is 3. So I want to make this obvious. And I'm going to add a note here that we use our slope formula. Next, we're going to find it from an equation. When we are given an equation in slope-intercept form, it'll look like this. y equals mx plus b. So our slope, we said before, is always represented by m. So if it's in this form, I want the number in front of x. So looking at my equation, y equals mx plus b, my m is that -3. So my slope is -3. Pretty nice. And then the last one is what we did in 2.2.1. So I just want to label my points and use my slope formula. So from a set of points, we're going to use our slope formula. So we have y2 minus y1 over x2 minus x1. And I can simplify that. I'm just going to double check. So 1 minus a -3, that does turn into a big plus sign, and then 2 minus 4 is -2. When I simplify this whole fraction, I get -2 as my slope. So my slope is -2. So that's how we find the slope from those 4 different representations. And we need to know that when we're asked a question. So in the 3.0 section, what the questions are going to ask is like which slope is steepest, or which slope is least steep, or which one has the greatest rate of change. And we need to be able to compare those. So down here we're going to talk about what it means to have a steep slope. So a line is steepest when the slope is furthest from 0. So if you remember Mr. Slope Guy, so this guy right here, if we have a slope of 0, that is straight across. That is not a steep line. A straight horizontal line is not steep at all. So the further we get from 0, the more steep we get, which means like the more angled our line is going to be. And so if we want the steepest, then it's the furthest from 0. If we want something that is least steep, we want it closer to 0. So a line has the smallest rate of change when the slope is closest to 0. So I want to make a note. If it has the smallest rate of change, that means it is the least steep. Those mean the same thing. Steepest means it has the greatest rate of change. Those mean the same things. And when we're talking about if it's furthest from 0 or closest to 0, we're not looking at if it's positive or negative. We're not looking at which number is like the biggest or smallest. So if we have -3 and a +2, -3 is furthest from 0 and would be considered the steeper of the two slopes between -3 and +2. So for this question, we have 3 different representations. So we need to figure out the slope of each, and then we need to compare them so that we can answer this question. Which of the following functions has the greatest rate of change? So the greatest rate of change, if we look back up here, is when it's the steepest. So we want the furthest from 0. So when we have a line, I notice that there is a dot here and there is a dot here. So I'm going to count my rise and I'm going to count my run. So the lines are kind of light, but that's okay. 6. Okay. I'm going to make little tick marks here. So this is 5, and then, so this would be like 1, 2, 3, 4, 5, 6. And this is like -1, -2, -3, -4, -5. Sorry that the lines are kind of weird. So when we do rise over run, we're going to go up 1, 2. Since we went up, our rise is a +2. And then our run is 1, 2, 3, 4, 5, 6. And we went to the right, so that's a +6. So this is our rise and this is our run. So our slope is going to be a +2 over a +6. And we can simplify that. I can divide both of those by 2 and I get 1/3 as my slope. So that's my first slope. My second one is an equation. And when we have an equation, we said we want to look for the number in front of x, which is this -1/2. And so I don't have to do any work for that. My slope is -1/2. And then the last one, we have a pair of points, so we want to use our slope formula. So I'm going to label these first, x1, y1, and x2, y2. So y2 minus y1 over x2 minus x1. When we subtract a negative, it turns into a big plus sign. So 6 plus 3 is 9. And then 2 plus 1 is 3. So 9 divided by 3 gives me 3. So when we are comparing slopes, if we end up getting fractions with different denominators, it would be helpful to change them into decimals. I think it's easier for us to compare decimals. And so I'm just going to write the decimal version underneath. So this is 0.3 repeating, and this one is -0.5, and then we have 3. And so this does make it easier for us to compare. So I'm just going to circle them in yellow, because these are what we are comparing. So to answer our question, which of the following functions has the greatest rate of change? The greatest rate of change means we want it furthest from 0. So between 0.3, -0.5, and +3. +3 is going to be furthest from 0. And if you need to draw a number line to help, that would be fine. So if I have a number line, and this is 0, and this is 1, this is 2, this is 3, and this is -1. 0.3 would be like here, -0.5 would be here, and then 3 would be here. So if I look at the distance from 0 for all of those, +3 is the furthest from 0, and so that's going to be the greatest rate of change. So for my answer, I'm going to say the pair of points -1, -3, and 2, 6 has the greatest rate of change. And so that's going to be my final answer. And we did it. So you guys are going to flip your paper or your packet over to page 7 to the independent practice. And there are 3 questions. The first question you are comparing 3. The second one you're comparing 2. And then the third one you're comparing 3. Make sure you pay attention to what the question is actually asking you. So this one is the least steep. This one is the steepest. And then this one is the highest rate of change, which is the same thing as the greatest rate of change. So make sure you know what it's asking you to find if you want the closest to zero or the furthest from zero, so you know which one is the steepest or the least steep.